Hello everybody. In the last class, we were discussing about circuit breakers, and before that, we have also seen what is meant by fuse. So, altogether, we have discussed uh, the important points, classification, and the constructional details, applications, advantages, and disadvantages of fuses and circuit breakers. Okay, in today's session, we'll be discussing some more points related to fuses. That is, in the last classes, we have just discussed what is meant by fuse and its classification along with its constructional details has been discussed. But as I have said, we'll discuss the ratings of fuses in the other video. So in this video, we'll discuss some points which are related to fuse, and those points are nothing but uh, ratings of fuses and the important terms which are to be kept in mind regarding the selection of fuses. Okay, along with some other factors include the selection of fuse for different kinds of materials will be discussed if time permits. Okay, so let's see, before going into the point of concern for today, that is important terms or fuse ratings, we'll just brush out the things which we know about fuses. So what I am going to discuss in within 1-2 minutes, these points will has already been discussed in the previous video itself, but just for continuity and brushing up the things, we'll discuss them. Okay, so fuse is nothing but an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Okay, the essential component in any fuse is nothing but a simple metal wire or a strip of wire that melts when too much current flows through it, thereby interrupting the current that is flowing into the load circuit. So, fuse is nothing but a sacrificial device. So, once a fuse has operated, it an open circuit and it must be replaced or it should be rewired depending upon the type. That is, here fuse is nothing but an overcurrent protecting device. Okay, so once the fuse uh, is blown out, it should be either replaced or it can be rewired depending upon the type of the fuse that is used in that application. Okay, there are thousands and thousands of different fuse devices which have specific current and voltage rating, breaking capability and response time depending upon the application. So all the applications do not specify the same specifications. Each application may demand different specifications. So based on the different specification, thousands of fuses with the various specific current and voltage ratings, breaking capabilities and response times are available these days. Okay, so altogether, in a simple statement, fuse can be defined as an overcurrent protecting device. The time and current operating characteristics of a fuse are chosen to provide adequate protection without needless interruption. So this point should be kept in mind, that is, time and current operation are, should be taken according to the protection without any needless interruption. Okay, the wiring regulations used will define the maximum fuse current rating of the particular circuits. Okay, this point also we have discussed in the previous session, that is, the fuse current rating will be decided by the wiring regulations of the load connectivity, and as well as the fuse for a particular component will be defined by calculating its fuse current rating of the particular load. So we'll take the power and voltage rating of the uh, voltage power and voltage rating capability of the particular load, and with that we'll be multiplying with the constant 1.25 value. The result what we get is the rating of the particular uh, electrical component. So that value will define that much amount of current that a fuse can withstand, and the fuse what that much current that component will withstand. And now the fuse what we have to use for that particular component should be more than the value that we have calculated. So if for example if the value what we have calculated for that particular device is some 7.5 or 7.6, then we have to choose a fuse which is a value which is greater than 7.6 or so. Like we can take a fuse which is some around 8 amperes or so. Okay, so this point should be kept in mind, that is wire regulations will define the ratings of the fuse. Short circuits, overloading, mismatch loads or device failures are the prime reasons for fuse operations. So the major causes or major problems which lead to fuse operation are nothing but either short circuit, overloading, mismatched loads or the device failure. So these are the major causes for fuse operation. So a fuse is an automatic means of removing power from a faulty system, often abbreviated to ADS, automatic disconnection of supply. Okay, so circuit breakers can be used as an alternative design solution to the fuses but have significantly different characteristics. So these points has also been discussed in the previous session, that circuit breakers will do the same operation what the fuse will do, but the thing is that they automatically get back to their original position once everything gets set right. Okay, that is a circuit breaker. So a circuit breaker does an additional operation when compared with the fuses. So coming to the construction of the fuse, a fuse consists of a single metal wire or a wire fuse element of small cross section compared to the circuit conductor, mounted between a pair of electrical terminals and enclosed in a non-combustible housing. Either most of the cases we see ceramic kind of fuses, ceramic or any other insulating kind of casing will be used for the construction of the fuse. The fuse is arranged in series to carry the overall current passing through the protected circuit. The resistance of the element generate heat due to the current flow. Okay, the size and construction of the element is determined so that the heat produced from the normal current do not cause the element to attain a high temperature. Okay, if too high a current flows, the current rises to a higher temperature that either directly melts or else it melts a soldered joint within the fuse that is connected to the circuit. So either when a fuse detects an overcurrent in the supply, it will either burns itself, either it because of the increase in the temperature completely the fuse will blow out, or it will melt any of the soldering joint that, to which the fuse is connected. So any of the case can occur when overcurrent is detected by a fuse. The fuse elements are generally made up of either zinc, copper, silver, aluminum or alloys to provide stable and predictable characteristics. So these fuse elements must be shaped to increase the heating effect. In large fuses, current may be divided between multiple strips of metals. So fuse elements may be supported by steel or nichrome wires so that no strain is placed on the element, but a spring may be included to increase the speed of parting the element fragments. The fuse element may be surrounded by air or by materials intended to speed the quenching of the arc. Either silica sand or non-conducting liquids can also be used like the which surrounds the fuse element. Okay. And coming to the advantages of fuses, the fuse is the most cheapest type of protection in any electrical circuit. Fuse needs almost zero maintenance. Okay. Operation of the fuse is simple and no complexity is involved. The fuse has ability to interrupt enormous short circuit current without producing noise or flame or gas or smoke. The operation time of the fuse can be made much smaller than the operation of the circuit breaker. So this is a primary protection device against short circuits. Fuse offers current limiting effects under short circuit condition. Fuse inverse time current characteristics has the ability to use for overcurrent protection. So these are some of the examples, advantages of fuses. And coming to the disadvantages, during short circuit or overload, once fuse blows off, replacement of the fuse takes place. During this period, the circuit will lose, circuit power will be lost for some time. So the interruption of operation will be done until the replacement of the fuse is done. When fuses are connected in series, it is difficult to discriminate the fuse unless the fuse has significant size difference. Okay, this point is to be kept in mind when using number of fuses, that too in series connection. Okay, and coming to the important terms like the ratings of fuse, or what are the points which are to be kept in mind regarding the selection of fuse, are nothing but these points. So we'll discuss these things in detail, right? So these points, like first one, we'll take the current rating of the fuse element. So what is meant by current rating of the fuse element? The current rating which the fuse element can normally carry without any overheating or melting is nothing but the current rating of the fuse element. That is the bearable current that a fuse handle is nothing but the current rating of the fuse element. Okay, depending upon the temperature rise of the contents of the fuse holder, fuse material and surrounding of the fuse. So these points like fuse holder, fuse material and surroundings will also add up to this current rating of the fuse element, right? Altogether, fuse element is nothing but, without any overheating or without any melting condition to occur, the point up to which the fuse, what amount of current the fuse can withstand is nothing but current rating of the fuse element. Next is fusing current. What is meant by fusing current? The minimum current at which the fuse element melts and thus disconnects the circuit protected by it. Okay, so the fusing current is nothing but the current which is slightly more than that of the current rating of the fuse element. For example, if the fuse rating is some 8, it is designed up to 8 amperes. If we apply a current of 8.1, which is slightly greater than the current rating of the fuse element, this slight or the minimum current at which the fuse will disconnect or the fuse will melt is called as fusing current. That is the starting current or the minimum current from which the fuse will blows out itself or melts itself in order to protect the load which is connected to it is called as fusing current. Okay, its value, if we apply current which is much more greater than the fusing current also, the circuit operation will remain the same. That is, the circuit will be broken down, that is, it will be now open circuited. Its value will be more than the current rating of the fuse element for around For a round wire, which is approximate relationship between fusing current is I and diameter D, then it can be given as I is equal to Kd to the power of 3 by 2. Okay. So if the fusing current I and diameter D is known, then the value of current, that is the value of fusing current I, can be calculated as I is equal to Kd, where K is a constant and is called as fuse constant, and its value depends upon the material with which the fuse element is made. So as we have already discussed that the fuse element can be made up of either copper, zinc, tin, silver, etc., aluminium, etc. So based upon the material what we use for the construction of the fuse, the value of K will depend. So in order to calculate the value of fusing current, we just use this formula with the knowledge of the element which is used for construction of the fuse element. Okay, I is equal to Kd to the power of 3 by 2. So the value of K in this table, you can see the value of K for the different materials is given. That is, for tin, the value of K is given as 405.5, whereas for tin 340.5. Iron, it is 777. Aluminium, it is 1870, whereas for copper it is 2530. So the value of K for every element will be a constant value. Based upon the value, the value of I will be dependent. The more the value of K, the more the fusing current. Okay, as I and K are directly related. So if you take for example copper and tin, the fusing current for copper will be more when compared with the fusing current for tin, as the tin has value of 405, whereas copper has a value of 2530. When we compare both these elements like tin and copper, the fusing current for tin will be less when compared with the fusing current of copper. So the value of fusing current is not same for all the materials. It varies from metal to metal. So the next point is the fusing current depends upon 4 different parameters, and those parameters are nothing but the material of the fusing element, that is what we have discussed right now, like if the material what we take for the construction of the fuse will decide the fusing current. Next is the length, how much winding or how much turns or how much strip of metal has been used, and its length will also decide the amount of fusing current for that particular fuse. And the size and the location of the terminals, either it is located or soldered, depending upon the location and the placement of the terminals, the fusing current depends. And it also depends upon the type of the closure used, like what kind of closure, like closing compartment we have used, will also help in deciding the fusing current of that particular fuse. Based upon these 4 factors, fusing current will be decided. Okay, so till now we have seen what is meant by current rating of fuse element. That is nothing but how much current a fuse will bear without destroying itself, or the maximum current the fuse will bear before it gets breakdown. That current is called as fuse current rating of the fuse. Second point is fusing current. This current is nothing but the minimum current at which the fuse will blow out itself for protecting the load which is connected to it. That is nothing but the fusing current. Next is, we'll see what is meant by fusing factor. So fusing factor is nothing but it is the ratio of minimum fusing current divided by current rating of the fuse. So Just now we have discussed two different points. If we divide those 2 points, we'll get another constant term, that is nothing but fusing factor. So fusing factor uh, is nothing but the minimum fusing current divided by the current rating of the fuse. So its value should be always more than 1, or else its value is always more than 1. And for semi-closed or rewirable fuse, the fusing factor will be generally 2. Lower value of fusing factor can be employed for enclosing cartridge type fuses using silver and bimetallic elements. So fusing factors will be lower for cartridge type fuses using silver or bimetallic elements. Okay, what is meant by prospective current? The prospective current is nothing but, or it is defined as, the fault current would normally have a very large first loop, but it actually generates sufficient energy to melt the fusible element well before the peak of this first loop is reached. Okay, the prospective current can be defined as a RMS value, that is root mean square value of the first loop of the fault current obtained in the fuse is replaced by an ordinary conductor or negligible resistance. Okay, the prospective current is nothing but when a faulty current which occurs will generally have a very large loop. So in that even that large loop is not necessary, uh, but small amount of that current in that loop is sufficient enough to melt the fuse. So that is nothing but the prospective current. So the prospective current can be defined as the RMS value of the first loop of the fault current obtained in a fuse, and it is replaced by an ordinary conductor of negligible resistance. Okay, this is meant by prospective current. Next is cutoff current. The maximum value of fault current actually reached before the fuse melt. This is nothing but the cutoff current. On the occurrence of a fault, the fault current has a very large first loop due to a faint degree of asymmetry. The heat generated is sufficient to melt the fuse element well from the first loop it reaches. Okay, so cutoff current is nothing but the maximum value of fault current that actually reach before the fuse melt. So we know what is meant by fusing current. So the minimum current at which the current fuse will blow off or which melt is nothing but fusing current, whereas cutoff current is nothing but the maximum value of the fault current, okay, which actually reaches before the fuse melts. That is the maximum faulty current which is able to melt the fuse, or which has a capacity to melt the fuse, is nothing but a cutoff current. So this cutoff value or the cutoff current value depends upon three parameters, that is nothing but current rating of the fuse, the value of prospective current, asymmetry of short circuit current. On these three factors, the cutoff current value will depend. It may be mentioned here that the outstanding feature of the fuse action is the breaking of the circuit before the fault current reaches its first peak. Therefore, the circuits protected by the fuse can be designed to withstand maximum current equal to that of cutoff value. So, this point is to be noted, that is, the circuits will be generally designed to withstand maximum current which is equal to cutoff current. Okay, so this is all about cutoff current. Next is pre-arcing time. Pre-arcing time. So pre-arcing time is the time that the time between the commencement of the fault and the instant when the cutoff occurs. That is, this will be very minute time duration, that is occurrence of fault and disconnection of the circuit, or uh, it is nothing but pre-arcing time. The pre-arcing time is generally very small. Typically its value will be around 0.001 second. Okay, so the time duration between the commencement of fault and the instant at which the cutoff occurs. Okay, so the value will be it will be very, the value will be very small, and this small value will indicate us that the switching action of the fuse is very fast. Higher the value of this pre-arcing time, higher the switching action it is. That is, how fast is this fuse is will be decided by this pre-arcing time. Okay, how quick the working of the fuse will be decided by the pre-arcing time of the fuse. So this is just a graph which represents uh, all the parameters what we have discussed right now. In this we can see a graph, a waveform we can see. This waveform is nothing but the faulty waveform. So this faulty waveform is nothing but a asymmetrical type of current. So it does not have same positive half cycle, and negative half cycle will not be same. Suddenly a fault has occurred. So in this you can see at 0 position, or else at 0 degrees, a fault has been occurred. So when the fault occurs, you can see that the maximum value will has reached at some point. Like here you can see the maximum value that is occurring in the for this faulty current. But you can see a cutoff current before the maximum current is reached. This is what I was telling you previously. Cutoff current is nothing but the current at which the faulty current, when the faulty current occurs, and in that faulty current which is sufficient enough to switch off the circuit or disconnect or blow off the fuse, is nothing but the cutoff current. Though we see here the maximum value of the faulty current, the fuse does not wait until the maximum value in the faulty current is observed. It just sees some value of cutoff current. So when it identifies an error has been occurred, it will directly disconnects a load from the main supply. Okay, and this time duration, that is from fault occurs and from the cutoff time, that time is nothing but pre-arcing time. Okay, so this point just now we have discussed the time at which the fault occurs and the cutoff action takes place. That time duration is nothing but pre-arcing time, and the time from which the cutoff has current has occurred and zero current reaches. That is, this current which is now cut off will reach to 0, as it does not have some 0 position, it has some value to it. This value from its cutoff current position, it reaches to 0, and this time duration is nothing but arcing time. Okay, pre-arcing time is nothing but the time from which fault occurs to the current cutoff time, how much time it has taken, that time is nothing but pre-arcing time, and the time from which the cutoff current has occurred and the time to the time the 0 value occurs is nothing but arcing time. So these two times, that is pre-arcing time and arcing time, in combination is nothing but total operating time. Okay, so these are the points or which has to be kept in mind regarding or when dealing with fuses, like what should be the value of the fusing current, or the current rating of the fuse should be known, and at the same time what is pre-arcing time and what is the cutoff current. These points should be known for the better usage of the fuse for one particular application. So without knowing these parameters, the selection of the fuse will not be appropriate, and sometimes it may lead to damage even the fuse is incorporated. So the proper selection for the particular application should be made based upon these factors. Okay, so current rating should be taken in mind, fusing current, pre-arcing time, and cutoff current values should be known when dealing with the fuses for any application. Okay. Next, what is meant by arcing time? The time extended between the end of pre-arcing time and the instant where the arc is extinguished. This is now what we have discussed just now. And next is total operating time. It is nothing but just now we have seen that the combination of arcing time and pre-arcing time is nothing but total operating time. It may be noted that the operating time of the fuse is generally low. It is up to some 0.002 seconds as compared to the circuit breakers. So when compared with circuit breakers, here what I can mention is that the operating time is very small when compared to circuit breakers. For circuit breakers it will be around some 0.2 seconds, whereas for fuses it will be 0.002 seconds. That is, operating time is very low, that is quick operation can be observed in fuses. A fuse in series with a circuit breaker for a low breaking capacity is very useful and economical arrangement to provide adequate short circuit protection. Okay, so all the times fuses, instead of using multiple fuses, you can use a fuse in combination with a circuit breaker in series with the circuit, so as to provide some economical and as well as low breaking capacity for the load circuits. Okay. Next is breaking capacity. It is nothing but the RMS value of the AC component of maximum prospective current that a fuse can deal with a rated service voltage. So this is nothing but breaking capacity. This is the RMS value of AC component of maximum prospective current that a fuse can deal with the rated service voltage. Okay, so these are the various points or the fuse ratings which are to be kept in mind when dealing with fuses. Next we'll see some desirable characteristics of fuse elements. So the function of the fuse is to carry the normal current without overheating, but when the current exceeds its normal value, it rapidly heats up to to the melting point and disconnects the circuit protected by it. This is the function of the fuse. The fuse element should have some characteristics in order to be considered to be as a fuse element. So not all the metals or not all elements are considered to be fuse elements. So there should be some set of points to be considered to make some metal to be considered as a fuse element. Okay, those points are nothing but fuse element should have low melting point. That is, it should melt itself with a small change in the temperature. Okay, for example, if we take a tin or lead, these metals have low melting point, so these can be considered as fuse elements. Next is high conductivity. So it should have in addition to low melting point, high conductivity should also be there for a fuse element. And next is free from deterioration due to oxidation. So as we will be using fuses in the most undesirable environmental conditions sometimes. So in those situations also the fuse should be able to function properly without any deterioration from the environmental conditions. So in such cases we can use silver. So silver can be used where uncertain environmental conditions are there, and if you want to reduce the oxidation process, there we can go for silver as fuse element. Next is the cost constraint, that is nothing but it should be of low cost. Okay, so examples for low cost fuse elements are nothing but lead, tin and copper. Okay, so these are the basic properties or the basic characteristics which are desirable for any fuse element. So altogether, tin, lead, silver, copper, these are the materials which are most commonly used, as these elements will fulfill these characteristics like low melting point, high conductivity, free from deterioration, and as well as low cost. Except the silver thing, all the other metals like tin, copper and lead will be costing less when compared with silver. So these metals can be used for the construction of the fuse element. So next we'll see what are the fuse element materials. The most commonly used materials for fuse elements are lead, tin, copper, zinc and silver, as just now I have told you. For small currents up to 10 amperes, a tin or an alloy of lead and tin is used for making the fuse element. Either tin or combination of lead and tin alloy is used for small currents up to 10 amperes. For larger currents, either copper or silver is used. It is generally it is a usual practice to use copper to protect from oxidation. Next is zinc. In strip type only is good if a fuse is used considerably for time lag is required. Considerable time lag is okay with your application, then zinc can be used, that too in strip format. That is one which does not melt very quickly with small overload. Okay, next is the present trend is to use silver despite of its high cost. So though it is costly, these days silver made fuse elements are in trend right now. Silver is preferred because of the following two reasons. That is, it is comparatively free from oxidation, and the second thing is it does not deteriorate when used in dry air. Next is the coefficient of expansion of silver is so small that no critical fatigue occurs. Therefore, the fuse element can carry the related current continuously for a long time. So this is a major point which made silver to be used these days. The conductivity of the silver is very high, and next is low specific heat is also one of the reason for selection of silver for fuse element, and quick interruption for short circuit current. So all these points put together made silver to be used as the fuse element these days. So one major or one point which differentiates silver from all other metals is that this oxidation and deterioration point. That is, it does not deteriorate even when used in dry air. This is the point which and the other thing is it is comparatively free from oxidation. So these 2 points we see for silver when compared with the other metals like copper or tin or zinc. So they may deteriorate and also they may show some oxidation properties, whereas for silver we don't see such things. So that is why silver is commonly used these days, even though it seems to be costly, right? So these are the points which are to be kept in mind while selecting a particular element as fusing element. Okay, you can choose depending upon your cost constraints, depending upon the environmental conditions, oxidation process, and also melting conditions, and all these points put together will decide what kind of fuse should be taken for your particular application. Okay, and also uh, we have seen many other points related to fuse in this video. That is, we have discussed the important terms like what is meant by fusing current, current rating of the fuse, what is arcing time, pre-arcing time, productive current. Next, we have discussed arcing, and all other timings have been discussed in detail with the help of a graph in this class. Okay, in the next coming videos, we'll be discussing some other points related to fuses, or if time permits, I'll show you a small comparison between fuse and a circuit breaker. So if you want to compare a fuse and a circuit breaker, so the fuse is nothing but, coming to the functionality, it performs both detection and interruption function, whereas circuit breaker, it performs interruption function only. The detection of the fault is made by the relay system. Next, coming to the operation wise, inherently completely automatically, whereas for the circuit breaker it requires an elaborate equipment, that is, we require relay for automatic action. So that is again to push back it to normal condition, we need again a different setup using relays. Next is breaking capacity is very small for fuse, whereas for circuit breakers it is very large. And operating time, this just now I have said you that operating time is very small, that is around 0.002 seconds or so for fuse, whereas for circuit breakers it is comparatively large, that is from 0.1 second to 0.2 seconds is the operating time. And coming to the replacement issues, fuse requires replacement after every operation. Once the fuse is blown out, it requires either replacement or rewiring. Whereas for circuit breakers, there is no replacement even after its operation. After certain point of certain time, it will again come back to its normal working condition. So there is no need of any replacement in case of circuit breaker. Okay, so these are the points which are to be kept in mind when we deal with circuit breakers and fuses. So with this, we'll stop discussion for today's class, and we'll see in the other points in the next coming classes. Thank you.